Okay, so in this video, we're going to review for the final some of the basic steps to naming coordination compounds, and then also go through 3 examples. So the basic steps would be that 1, you would write the ligands that are present in alphabetical order, and then 2, you would write the transition metal, and the third step is to add the transition metal oxidation state in parentheses after that. So then lastly, you would write any cations outside of the coordination sphere. So some exceptions to this rule are that polydentate ligands, you would not use mono, di, tri as prefixes, but rather bis, tris, tetricus, etc. And so some examples of these polydentate ligands are oxalate, ethylene diamine, diethylene triamine, and EDTA. And if something contains a prefix inside of it, example, ethylene diamine has di in it, then that's just another hint to use this naming. And so if the coordination sphere has a negative charge, you would actually add the 8 name to the end of the transition metal. Even if there are counter ions attached to it, as long as anything in the brackets adds up to a negative charge, you would use that. So some exceptions to this are that these naming compounds would actually be this. So rather than like cobaltate and just adding 8 to it, this would be what the name is if any of these were the transition metals. So you should just memorize those and also memorize the anionic and neutral ligand charts that we received in the course reader. So you can indicate the number of ligands with the regular prefix naming, like mono, di, tri, when you're listing the ligands in alphabetical order. And then any anionic ligands, what you can do is take away "ide" and add "o" to it. So rather than chloride, it would be chloro. Okay, so now we can go through some examples. So what is the name of the complex CrEn2H2O Cl in brackets and then Cl2 out of brackets? So first things first, you need to take a look at all of the ligands that you have. So you have ethylene diamine and H2O, which would be considered aqua, and then chloro. So what you first do is put them in alphabetical order because that was the first step. So it would be aqua would be first, and then chloro, and then ethylene diamine. Now, because there are 2 ethylene diamines, you have to use the prefix naming, but because that it's a polydentate ligand and it has the di in its name, then you need to use bis instead of di. So aqua, chloro, bis, ethylene diamine, and that is naming all of the ligands. Then the next step is to name the transition metal, which Cr is chromium. And then what you're going to do is you actually have to add up the oxidation states to find the oxidation state of chromium. So Cl is actually -1, so this would be -1, and then these two are actually neutral ligands. So it would be -1, and then in here it would be -2, -3, because each Cl is actually a -1 charge. So in order to counteract that -3 charge, this would have to be a +3, because then that would make the entire compound neutral. So this chromium would have to have a +3 oxidation state. So you would say chromium +3, but also because anything in brackets would be +3 and -1. So the oxidation state for the compounds in the brackets would add up to 2, and because it's not negative, you would not add 8 to the transition metal name. And then you would add anything outside of the brackets and coordination sphere, and so you would just add chloride at the end of it. So then the next problem says, what is the name of the compound of the complex CuNH3Cl5 3-? So the ligands that you're dealing with would be ammonia and chloride. And so first you would add them in alphabetical order. So this would be amine because you just need to memorize that on the chart. And then you have 5 chlorine ions, so it would be pentachloro, because whenever you're using the anionic ligands, you always add O to it. but the naming is easy to memorize if you just look at the chart that we were given in the course reader. So this would be amine pentachloro, and then Cu is actually one of the exceptions that we went over, and so it would be cuprate, and chlorine is -1 for each chlorine atom, and because you have 5 of it, the charge of this would be -5 because this is actually a neutral charge. So if the entire thing is -3 and this is -5 and this is neutral, then you know that this has to have a +2 oxidation state, and so you can write that, and that's just the completed name. And then what is the name of the complex? NaCO NH3 3Cl. So what I found is that anything that is outside of the coordination sphere but at the front of it, you actually list first. So Na you would list as sodium, and then you would just go into whatever you would do. So then this would be the ligands you're dealing with, which is triamine, because you have 3 ammonia ions, and then 3 chlorine ions. So it would be triamine, trichloro, because you're still following the alphabetical order. And then the transition metal is cobaltate, because this would add up to a negative charge, because this is -3 and this is 0 and this is +1. So you know that cobalt would have to have a +2 oxidation state, and so this would be negative, so you'd have to add 8 at the end of it. And that's basically it.